Alrighty. Good afternoon, everybody. Welcome back to Discrete Math. So, several things I need to talk about. First of all, I think for the foreseeable future, I'm going to start recording classes just because we have a lot of students today and probably more to come that are out sick, and especially because it's such a participation class, I want you to feel like you're sort of part of the class environment. So I'm going to be recording classes and posting them on YouTube, and I will be sending out a link probably sometime tomorrow to my YouTube channel where you can see links for classes going on. Just because links are up on YouTube doesn't mean you should stop coming to class. That's if you're sick and you're worried about infecting students, or if you're just kind of generally worried about COVID. And if you're worried, let me know. You're okay to miss class. If you miss class for extended periods of time, we will probably be doing things like, I don't know, Zoom presentations and such. How horrifying. But we'll see as time goes on. Those of you watching this, I'll be in contact with you soon. Plan for today, existence and uniqueness proofs. I wanted to talk to you about that. Friday, I was gone. Sorry, speaking of people missing class for being sick. I think turns out I got tested for COVID. It wasn't COVID, I think I had a cold. But I'm feeling a lot better now. Thanks for those of you who sent well wishes. Plan is, I just decided the easiest thing to do, considering I was hoping to have another class before you had to turn in portfolio stuff. 2 entries due Friday this week, and then that'll just, I think, is the simplest way to get things by. So plan for this week. Today I want to focus on the uniqueness existence proof stuff that you all started working on last time. I was going to give you some more time today. Wednesday, we're going to do some other different types of proofs: direct proofs, proof by contrapositive, proof by contradiction. And then Friday, we will be doing something else. So, would you all? I promised you all that you would all have some class time on Friday to continue discussing the existence uniqueness stuff with your fellow classmates before we did presentations. I was planning on doing the same thing today. Do you all like some extra time to just kind of talk over in small groups before presenting to the class? Yeah. I'm seeing a lot of yes. So that's gonna be the plan for today. I'll give you the first 15 minutes or so to work kind of talk things through with some of your classmates. And then in the second half of class, we'll do the existence uniqueness presentations. And then I actually have some homework. Oh yeah, I forgot. I have more homework for you. Got a new worksheet for you. Other proof types, direct proof by contradiction, proof by contrapositive stuff I mentioned. I was thinking what we could do is, today we're going to do existence uniqueness stuff. Your homework for Wednesday is to take a look at this new worksheet packet and start thinking about the proofs in this. And then in class on Wednesday, first half of class, I'll let you kind of talk to your classmates in small groups again, talk about what you found, what you thought about the different proofs in this packet. And then we'll do presentations for this in the second half of class on Wednesday. And then Friday, we're not going to have any presentations. Instead, we'll be doing something else. Sound good?
You're just really trying to build the momentum towards Friday and hype it up, aren't you?
Field trip.
It is. Field trip. Where do you want to go on a field trip?
I don't know, this is my guess.
Thing is, I haven't actually decided what we're doing Friday, so I'm hyping myself up now. I need to try and come up with something great.
When I took Calc 3 in high school, we went on a field trip to outside where there was a hill, and then we talked about partial derivatives.
Well, we could do that. Replace partial derivatives with maybe set theory and I
It
can
was
work.
pretty fun, because then we had like the visualization of like, oh, you're trying to find the slope at this point.
Well, that's pretty deep.
I know.
Anywho, that packet is for your homework for tonight. Plan on looking over the packet, taking a stab at the proofs within, and then first half of class Wednesday, you'll be able to work in small groups, talk to your classmates about this packet I just passed out, and then second half of class Wednesday, presentations on it. All right, with that in mind, I don't remember what groups you were in last Wednesday, and several of those students are missing anyway, so
There's also the very questionable glasses group, which did not include all the people's glasses.
oh yeah, the glasses column we've got going on here now. Am I missing anyone? Yeah, now the glasses column. So tell you what, split yourselves up however you want.
I would like to reconvene the glasses group, though I am no longer wearing glasses.
Okay, I didn't really do
But we don't have Lily today.
One
Impaired.
announcement. At 1:20, we will reconvene to start presentations.
That was quick.
What all right?
Yeah, pretty good.
I have a stab at number one.
I just got like
lost.
Are we on the unique?
for this one.
I was on it too.
Oh, I'm gonna put like the sign-ups on the board for the different problems. Do you want me to leave you up for?
I don't
any
care,
of
yeah,
them?
just not the last one.
Just not the last, okay, I can do that.
Then must be
I don't know how good my proof method does not exist online is, but the rest was nice.
Yeah.
Rude.
I'm not giving like.
And then I
figure out who's mine, but it has like 12.
Two.
So I found.
And I found it. Are we talking about number two?
I think that would work. What I did is I said, if they all line, you can take any 2 points and find the equation of that line. And then that equation will satisfy all 3 points. So I took like 0, 1, and 1, 3. Found the equation line goes to both of them and proved that 1 or 8, 1 is on the line.
I just copied what you did. There was one like really similar on the page geography.
So if f of x equals e to x minus 15 had to go root, it does, root x minus 15. So we just say e to the x1.
At any point between now and when we start presentations, feel free to go sign up for one.
I didn't really know.
Suppose that f of x has 2 real roots.
I kind of watched the exam that gave us. It's rough on fire.
I forgot.
So you really.
Did you show that that makes these two statements true? So there does exist a function, if not unique.
So there's two.
Right, yeah, I feel like that's kind of simple enough.
Like,
Yeah, so then for the unique.
Then you natural log.
But I started with the derivative of x.
Because the 15 will go away.
Yes. I loved it for a very long time.
Oh,
Yes.
I was like, what?
So I got f of x equals sine of x plus y.
Wait, the indigo of gold?
At prime of x.
Apply the natural.
So I started the base equation.
Oh, okay, yeah.
So I didn't know what mine. And then I got this one. So
So you just.
that just gives me sine of x plus
So you
y.
Is this for the e to the x minus 15?
Yeah.
Yeah,
I think the camera's.
Yeah, so what I
It is.
just did was I just said, assume there are 2 distinct.
I don't remember where the camera is in this class.
Such that.
I think it's coming
Or
up.
f of x1 equals 0 and f of x2
There we
equals 0.
go.
So
And
You're
then you
almost
just plug
there.
that in, so you get e
Step
to
back a little
the
bit.
x1 minus 15
There we
equals
go.
0.
Then I guess
You get e
this
to the x2 minus
Very
15 equals 0.
Yeah.
And you just solve for x1, x2, and you show that they must
It's just
both
x1
natural and
equals
x2. So they have to
That's
be
like the
there
x1
can only be one real root.
It's like
the function of pi over 2.
Yeah.
Then I plug that
Okay,
into
each what power gets you e to the x.
and sine of pi over 2 is 1. So the function of pi over 2 equals 1
Yes.
plus y. And
We're
in order
there.
for this to equal 1, y
So
must
that
I
was
do not know how to do
x
the
one
second
equals
one.
x2.
Yeah, but I
And I was
I
like,
don't get what I'm saying.
I just made something up about it being a. what I said.
I walked in
Not
that.
only-
So I gave
the
the
equation, it's only one solution, but I don't think it's two.
second half of that seemed pretty
Technically, it's
true, what I
They
got.
can't get 2 different roots.
Yeah.
Roots.
Yeah, it totally makes
the root
sense.
had,
Yeah,
Damn.
how's it going?
feeling good about this. Sign me up. Week number 1.
Okay, you already talked to each other about
See all
that?
the garbage.
Okay, cool. In that case,
Prove that there exists.
for you to start taking a look at the next one.
Proof that there exists a unique function f of x such that f
And possibly consider signing up.
cosine of x.
That's just the suggested.
How are you moved today,
F-
Joe?
f of
Yeah, I think you're just gonna choose one.
Well, let's see. Alright, Olivia.
Another sign of.
Oh, you didn't present last class either, Olivia, so.
both existence and uniqueness.
Well, I
I'm
think I
not
did
sure
present
if
last
that's
class.
exactly.
Sine.
Now, you presented the third and the
Yeah,
sixth,
so we
have
can
you
show
down
that.
for.
That's just what I would do to compare that.
So like
Yeah.
last Monday and the Friday
I
before.
really consider it the beginning.
That they must be the same. I think the
Really?
difference is that
It's not.
You're talking about notes back in my office.
we can put anything. And
Okay.
this could be.
So
y,
if that's
but-
Prime of x.
Prove this claim.
And this is actually
And unique.
Right,
It exists.
but I guess my
Exists.
trouble is just.
So now we need to show the sign of
Like,
x1.
really found an answer, but.
No,
Equals
it's
1.
just like not one.
I think that.
Well, sign of x. X.
Oh, x, sorry, I thought you were
a
saying
unique
sign.
function f of x such that
So
f prime of x
you
equals
wouldn't-
cosine of
wouldn't
x.
be a variable.
I don't think I'll sign up for.
And
So-
unique because f of prime of x.
Can we prove its uniqueness or do we just,
So you
or
think that's part of
the-
the problem and not necessarily.
because it's not really unique, because it hits one every too high. When you say that that is part.
Well, I mean,
Right,
but there's
we're
only
like-
one function
Just
That-
listening,
that
it's,
the fact that
satisfies
this
the
function
derivative
is-
of f
Like,
prime
we
of
don't
x equals
necessarily
cosine
have
of x
to
and
Unless we just have
f
to
of
prove
pi
that
over
it
2.
exists.
No, I think we do have to prove that
There's only one,
but I think that
There's only one function that does that.
And that's
Has to
both.
be deducted.
Oh,
so
So- so-
No, I
Yeah, I
can,
think you're.
I can barely spell half of them.
Right, exactly,
Those
but,
are, there are two
so
functions
like,
that satisfy f
yeah, this
prime
isn't
of x
necessarily the end of the
cosine of
equation,
x.
so
g prime of x equals cosine of x.
sine,
And then f of pi over 2 equals 1.
pi
And then you go from there and prove that they have to be equal
over
to each
2
other,
plus y,
which would demonstrate uniqueness.
so. Sine.
I see.
Yes, I'm not exactly sure if this is actually proving anything.
What do you say? What do you say again?
So,
Sorry,
in
I
this,
was-
in
I
this
was-
Nine
case,
pi over
suppose there are
cosine pi over
two
zero.
functions for which
So-
f prime of x equals,
The y.
like suppose there are two functions f of x and g of x
That's
such that f
the
prime of x
closest that I
and
think
g
you
prime
get
of
to
x
not
equals
showing that
cosine
there's two things that
and
work
f
and those two things
of
are
pi
the
over
same.
2 and g of pi over 2.
well, listen.
Yeah, uniqueness.
To show that they're equal to each other is this.
It's not what I had in mind. I'll put it that
So if
way.
you just have that y prime equals cosine of x, you have infinitely.
I was thinking of using just Calc 1 theorems to say like, oh, if F1,
That,
if F1
So
prime
you
is
just
over
have 2 equals
prime,
1, that
then
narrows
F1
down
and
to 1,
F2 have to differ by a constant, what could
but I
that
think that's just, I don't necessarily how to rigorously prove it, I could just kind of like learn that. It was just an IVP, and then
So just
whenever
like
you have
more
an IVP, first order
logical,
IVP, just the
like
one
a-
condition.
Well, I mean, using
Or
Calc 1.
argument versus like a symbolic.
Well, you can use that Calc 1 result, that's the idea here. I'm more interested in seeing, do you know how to write this as the existence and uniqueness type thing, more than do you know your calculus? Go on to take real analysis, you will get to prove such results. Carry on.
Seriously.
Yeah, I just said I just wrote it was a first order non-homogeneous differential equation
Yeah.
with an initial
Like, think if you're
condition.
9 minus 11.
So that means you can narrow it down.
I know, and I feel like it's wrong. It's wrong.
Okay, so we'll do that.
Sorry.
Oh, okay. I gave it away. How many people know about this?
I just went to Wisconsin. I think it's on like is that the towards the eastern side of the state? On the lower right? No?
No.
Completely wrong.
Western, but it's not too far from the Twin Cities. Minneapolis.
Oh, okay, I'm thinking of your Twin Cities, Wisconsin. Okay. I get the order. I always
Minnesota, Wisconsin.
feel like, yeah, where they are.
That'll do that. A lot of people in the take 90 photos. So every now and then you come across someone who's like, oh yeah, I drove through that to get to somewhere more interesting.
See, the discussion's kind of died down here. Everybody feel like about ready to move on to presentations? Okay, is there anyone who wants to sign up who hasn't yet? Alrighty, in that case.
Let's go, Griffin.
Alright, let's see. I should start from the left. I don't know why I would start from the right. I should start from the left so like whoever's up first can start writing things down while I go through the rest of this. If you want to go ahead and start writing, you can.
Probably really good at me. I feel like I'm more likely to teach humanities, but I'm in a really big class right now that also requires us to co-teach, so good teaching experience this semester. Yeah. Yeah, it's kind of nice. Our religion course is like we're literally just at a table in a conference room. Because apparently 10 a.m. on Monday is like Monday, Wednesday, Friday is like the busiest time, and so the only place there was a conference room in Dell. So that's where we are. Nice.
All right, I think we're ready to get started with our first presentation. So, Alex, kick things off for us.
Okay. So this first existence proof asks us to consider the following. There exists a non-zero integer in such that, oh, I wrote x, but you get the point. It asks us to consider there exists a non-zero integer in such that n cubed plus 8n equals 0. So I went about proving the existence of that non-zero integer in the following way. First, I said, let's consider a non-zero integer x equals -8. Okay. Then, really matter just algebraic manipulation. You plug this in to the equality up there. So -8 cubed plus 8 times -8 squared. Does that equal 0? Well, okay. -8 cubed is -512. Okay. Plus 8 times -8 squared is 64. And then just the next step in the algebraic process. 8 times 64 is the same thing as 8 times 8 squared, which is 8 cubed, which is, again, 512. And since -512 and 512 are additive inverses of each other, we do arrive at 0 equals 0. Since the equation is satisfied, this equation does have a non-zero integer such that it's satisfied. Any questions?
Nice job, Alex. All right, I'm gonna pick on you a little bit, Alex. You can sit down. So typically, if you have like sort of a string of equations that you want to consider as part of a proof, instead of trying to say, does this equal 0? Does this equal 0? Does this equal 0? 0 equals 0. Look, I've drawn a pair of glasses. In general, the strategy you want to use when approaching like a string of equalities like this, or like some algebraic stuff, like algebra in the middle of a proof like this, typically what you would do is you would start with just the first expression, like then negative 8 cubed plus 8 times negative 8 squared. And instead of saying, does this equal 0? Instead, it's best to just kind of go saying this is equal to what? Negative 512 plus 512. And then this is equal to 0. And kind of make it flow like it would like a single sentence. So basically saying then this expression is equal to negative 512 plus 512, which in turn is equal to 0. And just instead of having this, does this equal 0? We don't know the whole way. Just because it's sort of logical. And the reason why is mostly just kind of convention, but it sort of preserves more of a logical flow of thought. Then if we plug in negative 8 into this expression, it comes out to 0, whereas having to ask sort of a bunch of questions along the way that you then answer. This is a Socratic, a Socratic proof. But this is kind of more the norm going forward. So just in the future, when you write proofs that involve like a bunch of algebraic manipulation along the way like this, it's best to just at each step simplify and then show at the end that it comes out to what you want it to be, rather than doing something like this where you go through and ask yourself throughout. Any questions or comments about that? Great. Yeah, otherwise, nice job, Alex. That was well done. Okay, Laura, the next one.
Is there an eraser someplace? There it is.
There's a lot of erasers.
Yeah, I see those little basketballs. Alrighty, so got number 2. I'm supposed to show that there does not exist a line. Is there like a symbol for does not exist?
You write the backwards E and then put a slash through it.
Alright, so there does not exist a line that passes through, there we go, points 0, 1, 1, 3, and 8, 1 in the plane, guessing that's the xy plane. So in order for there to be a line that passes through all of these, they would all have to satisfy y equals mx plus b, where we already know our x and y values. We'll substitute some sort of, or we'll insert some sort of b value. But the important part is our slope right here. So in order for this line to actually exist, we must have an n that can satisfy the slope between every single point. So check the slope in between 0, 1, and 1, 3. It's a pretty simple y2 minus 1 over x2 minus x1. So that'll give us 2 over 1 slope, and then checking that from 1, 3, and 8, 1. The slope of that is going to be, again, -2 over an increase of 7. And these, so here, we'll go equals M1 equals M2, and M1 does not equal M2. So there cannot be a straight line that connects all 3 of these points. And I think that proves my point. Any questions, comments, concerns? Sweet.
I have a question. I like the way you approach this with the use of slope. I thought that was a good way to go about it. Could you maybe write like a sentence at the end explaining what you found?
Okay.
You were saying a lot of good things out loud that didn't quite make its way to the board.
Okay, so if such a line exists, there is exactly one value that satisfies M. That satisfies. Well, I'm not sure if that's exactly the best way of writing it either, because if I just had 1 point, there would not be exactly one value, but there would be a line that exists through there. Does anyone have a way that they would write that? I see Adam, Griffin. I don't know who to choose.
Griffin, go ahead.
Okay.
I think you could say that a line by definition has a constant slope, and because there's not a constant slope between the points between the 2 lines that you made, therefore they do not all exist on the same line, but exist on different lines.
Okay, yeah, so like a line must have a constant M. Through every point, or in between every single point.
And you could just say that 1 and 3 create a different line than 1, 3, and 8, 1.
I honestly feel like the way you were writing it was fine, because it's like, you have the condition up top. So if you say if such a line exists, you're like saying if
Such
there's
a line that satisfies these
Yeah,
3
you're
points.
already saying that, so I feel like the way you were going was fine. I don't know.
That's what I was gonna say, I think you're fine.
Yeah, I was like, I think it's fine.
Sweet.
Should have made her write out the whole sentence over there and then told her.
That's what I would have done.
Do you have any comments, Dr. Gersel?
What do you mean when you say there is exactly one value that satisfies M?
Well, we found here 2 different values that satisfy M for like these mini equations, if you will.
So by satisfies M, I take it you mean could be the slope.
Right, or that is a slope between any 2 points.
Slope of the line between any 2.
Yeah, there must be exactly one value of M between each point. Or each set of points. That makes sense to me. Yeah.
Okay, I have an unrelated question. I should have asked it earlier, but I think slowly. So I like how you did like showing that the slopes have to be the same, but as an alternate way to do this proof, could you have written out the line that goes through 0, 1, and 1, 3 in the format y equals mx plus b, and then plugged a 8, 1 into that line to prove that it was that such a line did not exist?
I think that's appropriate.
Ooh, Mariah, that's an interesting idea. So basically, fully find what the line passing through say the first 2 points and then the third point doesn't satisfy the equation for that line. I think that would be a great way to go about it as well.
Anything else? Oh, okay, wait, oh.
Your proof relies on values of m. What if you have vertical lines
Vertical lines, what do you
with
mean?
infinite slope?
Oh,
Now I'm just picking on you, but
oh, that's interesting. Well, I think you'd still come up with the same result, would you not? Like, you could still do like 2 over 0 and 2, or it would be some numbers over 0, which would be your, infinity or whatever. So like, I guess your numbers wouldn't exist, but you could still compare them in the same way. It might not technically work mathematically, but it would make sense at least. Yeah, Adam.
If you're also looking at the case of vertical line, that means they all have all points with the same x value. So if you look at 3 points and they don't all have the same x value, then they cannot lie.
True, yeah, I suppose you just have to write a different proof for that case, where you look at your x values.
Are there questions or comments for us?
All
All right, nice job, Michael. You're my guinea pig. I wrote this one because I knew it would be tough to write out a proof, that there's several different directions you could go and lots of different cases to consider. I want to illustrate the point, though, that as silly as my comments may have seemed, later in the semester we are going to have to consider problems like this where we could have several different cases to consider, or potentially several different ways of how you might write up a proof like this. Yeah, nice job. I thought you did a good job with this.
Okay, I'll be doing the first uniqueness proof. So it asks us to prove that if f of x, which is equal to e to the x, e to the x minus 15 has a real root and we're told that it does, prove that this root is unique. Okay, so I started off by saying, assuming, kind of like the example did, that there were 2 roots. So we have e to the x1 minus 15, and then we could also have e to the x2 minus 15. And so to solve for the root, you would set them both equal to 0. So we'll connect them. And then it's just a matter of solving it and figuring out that they both have to equal each other. So if we add 15 to both sides, because I don't need to, it would equal e to x1 equals e to x2. And then using the properties of log, we'll natural log both sides. And then this is saying, so e to what power gives you e to x1? So x1 is the power that we'd raise e to get e to the x1. And the same thing on this side. And so now, since if you suppose that there's 2 different roots, they must equal each other at the end, then there's only one root. Are there any questions? Yeah.
Are there any functions you can think of that this would not be true in the case of?
That there's not a
That-
unique root?
Yeah, I guess, would there be a function that exists that both of them could say equal 1, but they're not the same value?
I mean, I'm willing, if I would guess that there's probably one. I can't come up with one off the
Okay.
top of my head. I mean, there's gotta be 2. equations that have different roots.
Let f of x equal x squared. And
They could
if you plug in f of 1 and f of negative 1, it'll give you the same outcome.
Yes. So I guess my question is, does this prove uniqueness then?
Well, yeah, because we used it for these, not for x squared.
Okay.
Right, I guess maybe I don't get what you're asking then.
Would it be like if you were using the function x squared, then when you took the square root, you would have a plus or minus option, which would then give you like two options instead of
Right.
the natural
Okay.
log.
Okay.
We will be talking a lot more about this question in chapter 5 when we get to theory of functions.
Is there any other questions? Yeah, Dr. Gerstle.
So Jacob, looks to me like you have some x1 and you claim that e to the x1 minus 15 is equal to e to the x1, and that's equal to the natural log of e to the x1.
Or e to the x1 is equal to e to the x2 minus 15.
Okay. So what are you saying is equal to e to the x1 then in your next line?
In this one? What are you saying?
Yeah, you say something something equals e to the x1 equals e to the x2.
Oh, sorry, that's just like, do you not do that for proofs?
No. If you claim that they're equal, you can.
I just meant like, I guess I've always done that when I'm doing my work, like next line.
So I'm going to introduce a new symbol here that you can use as markers. You could let's thank Jacob, please. So yeah, this is a common thing math students do, which is why I want to nitpick it to death. I think this could be a symbol you could use instead if you wanted to. Basically say, like, have the implication arrow, which is basically saying therefore. You'd say like, if e to the x1 minus 15 is equal to e to the x2 minus 15, or then e to the x1 has to equal e to the x2. Like this implies e to the x1 equals e to the x2. That in turn is going to imply that they have the same natural log. And then here you could actually use just this equals x1, this equals x2. So yes, Isabel.
So when we're doing a uniqueness proof, do we have to do it with this way, with like proposing like an x1 and an x2 and then showing that they have to be the same thing, that there's only one?
This leads to my next question. Did anybody have a different way of proving this? To answer your question, Isabel, I would say it depends on the problem. If you have another way of doing it, you can do it another way. Did you have another way in mind?
Well, I guess I just didn't know like if you could just solve the equation and show that x is the natural log of 15 and then like I guess
that's
it's
the
not
only
like a good
solution?
proof. Well, yeah, I guess because that's not like a good way of doing it, but I guess it's just like there's no other answer. Like it is the natural log of 15.
Sure.
That sounds bad, but
Ooh, that sounds like a great way to prove f of x equals e to the x minus 15 has a real root. The question though of how would you then show that root is unique? I think would then either have to come from something like you can explain as part of the process of finding this root, I determined that there couldn't be any other roots. And then you'd have to refer back to what part of your work shows that. Maybe like something like this. You could say if e to the x minus 15 equals 0, then e to the x has to equal 15. So x equals natural log of 15. Is the only solution. Would be a way I think you could do it based on something like what you described.
yeah.
Yeah, that's good. That's a good question. I'm glad you asked. In general, this is the standard way of proving uniqueness is assume there's two, show that they must be equal. But depending on the type of problem, it doesn't necessarily have to. I bring this up because what you described as well works great for this type of problem, like show that this show that this function has a unique root. Another way you could have done this, by the way, is say, Note that f prime of x equals e to the x is always positive. Therefore, this function is always increasing. Therefore, it can never take on the same y value twice. Therefore, it can't have more than one root. Would have been another way to do this, involving a little bit of calculus. Most of this class, we're not going to be answering this type of question, finding roots of polynomials. If you want more of that, take a numerical analysis and/or real analysis. It's more of a continuous math flavored question, but it depends on the context is ultimately the answer to the question. Jacob, the way you kind of approached it is kind of the way that I think is going to be most transferable to other types of proofs when we get into uniqueness proofs in, say, set theory or talking about relations later in the semester.
That's what I was thinking, so.
I'm glad. Yes, Silmer.
Okay, so I think I melded the two ways together, so I just want to ask you if what I did was legitimate. So I did that e to the x minus 15 equals 0 down to x equals natural log of 15, except I just wrote that equation twice, once with an x1 and once with an x2, and then since they both equaled the natural log of 15, at that point I said x1 equals x2. Is that?
So you basically wrote this all out with an x1, and then
next to it,
and then next to it you did the same thing with the next two replace?
Yes.
My gut answer is that's weird. Is it logic? Does it logically work? I think not necessarily. I think just because you happen to get the same answer twice doesn't theoretically mean you couldn't do it a third time and potentially get a different answer. So somehow your proof needs to encapsulate the fact that no matter how many times you try, you're always only going to be able to get a single solution at most. Jacob, by the way, as part didn't actually prove that a solution existed as part of his proof. He didn't have to because the problem didn't ask him to. But this would have been a way you could have proved existence and uniqueness at sort of the same time, almost. You say like, aha, look, this is a solution, and it is also the only solution. You look unhappy with that.
I'm sorry, I'm confused. So,
Okay. Well, that's why I wanted to give plenty of time for the presentations today, because I knew we would have some serious discussion going on.
okay. So wait, if we did it my way where you have just the same equation done twice, because natural log of 15 is like a real number with no variables in it, would saying x1 equals this single real number and x2 equals this single real number, does that prove that that's the only solution? And
Not
if,
necessarily.
There's a variable in there that could be ambiguous?
Not necessarily. Here, I'm going to do a counterexample, I think, where I'm going to try and use your approach to prove something that is not true.
Okay.
If that's okay. So here's my faulty proof. Don't try this at home. Claim f of x equals x squared minus 1 has only one root. This is wrong. There's two roots, plus or minus 1. Figure out the problem in my proof. If, let's see, x squared minus 1 equals 0, then x squared equals 1. X equals 1 satisfies this. I'm sorry, I got caught up in my counterexample and I forgot what your argument was. Can you repeat your what you were saying, Ulrich?
I think I would have said then. What would I have said? Sorry. Can you step that way so I can see this? Thank you. Okay, I think I would have said x1 squared minus 1 equals 0, and then next to it I would have said x2 squared minus 1 equals 0, and then I would have worked those both all the way down.
Okay, so then you would have gotten something like x1 squared 1 equals 0. Okay, So here we would have gotten both x1 and x2 squared would have had to be equal to 1.
Why wouldn't you have to make them equal to plus or minus 1?
Well, the squaring. The x1 squared has to be 1, x2 squared has to be positive 1. And then when you solve for just x1 and x2 individually, you're right, you could get two different solutions. So what's the, so since the fact that we could get two solutions would mean this claim is false. Okay, so sorry. I had something different in mind for what your argument was going to be. Let's have a conversation in office hours about this, because I feel like because I want to talk to you more about your ideas, but I don't want to take up too much class time going on. That's okay.
Yeah.
Yeah. To sum up this proof, take this off. I don't like this. Here's how I would sum up this proof for a uniqueness proof. In general, you always want to write out your thoughts in words. So, Jacob, I think you had like all the correct pieces, but you needed like some more words, like maybe at the start writing out, assume x1 and x2 are both roots. Then e to the x1 minus 15 equals e to the x2 minus 15, which arrow, blah, 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 arrow, blah, 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 arrow, x1 equals x2. Thus, the root must be unique. Actually writing out kind of all your thoughts in words. You were doing this I think I noticed you doing this a little bit too, as you were saying a lot of good ideas in words, but they weren't quite making their way onto the board as part of your proof. Keep in mind that the proof needs to consist of complete sentences. And yes, this is a complete sentence, mathematically. E to the x1 minus 15 equals e to the x2 minus 15. This equation implies that e to the x1 equals e to the x2, which implies that x1 equals x2. Not the sort of sentence you would give to your English professor, but to a mathematician, that's a complete sentence. Whereas just strings of equations with kind of no way of really connecting them isn't. And then preferably your proof has like an actual written out in words sentence at the start or end to explain what you found, what you're doing. Something like, suppose x1 and x2 are both roots, then blah. Thus, there can only be one root. Making it very clear. Hypothesis, stating out in words what you're showing. Conclusion, what have you found? I want to go through this very slowly because this is going to be something you're going to have to do the entire rest of the semester. So I really want to try and drive this point home now. Any questions or comments about any of that? Okay, tell you what, Griffin, how about we start class on Wednesday with your proof?
Sounds good.
Okay, so in that case, here's your homework for Wednesday. Take a look at the other proof worksheet, the direct proof packet, the direct proof, proof by contrapositive, proof by contradiction. And when you're writing out your proofs, one thing I want you to focus on is making sure that you use words when appropriate to explain what exactly you're doing throughout different parts of the proof. Because that's a very challenging thing to do early on when you're writing proofs. So on Wednesday, we'll start with Griffin's proof. I'll give you some time to talk in small groups, and then we'll probably do something like half the presentations from this packet on Wednesday, the other half on Friday is what I'm guessing is going to happen. So with that in mind, you all have a good rest of your day. I'll see you all on Wednesday.